Now that you know how to actually figure out what's being oxidized and what's being reduced in a redox reaction, and you know how to draw the half reactions of what's being oxidized and what's being reduced, we're now going to take those half reactions and balance the entire reaction by a process called the half reaction method. And if you go to your blue Barron's review book, you can see that there's two different methods that are listed: the ion reaction method, and then there's the half reaction method. We're always going to use the half reaction method, and that's why I had you guys writing half reactions from the previous flip lesson. Now the steps for the half reaction method are all listed out right here, but the best way to teach it to you is to actually walk you through an actual half reaction balancing redox equation problem. So I'm going to give you this reaction right here that's just a typical redox reaction. And the very first thing that you're going to need to know how to do is all the way from our first flip lesson, which was write out the oxidation numbers. And since we already know how to do that, I'm just going to go quickly and just write in all the oxidation numbers of all the substances that are in this chemical reaction. When you look at it very carefully, you got to figure out what's being oxidized and what's being reduced. That's the very first thing that you should figure out once you put in the oxidation numbers. So we got to look at it very carefully, and remember the oxidation is the loss of electrons, so you're looking for a substance whose oxidation number is actually going to go up. Because you're losing electrons, the oxidation number is going to go up. Well, that would be calcium right here that's undergoing oxidation. It goes from 0 to +2, so that's what's being oxidized. And the element that's actually being reduced, well, you have to look carefully again. Nitrogen is actually being reduced. Now, some people would say, well, if you look at this nitrogen right here, the oxidation number doesn't change, but that's true. But this nitrogen's oxidation number does change. It goes down from +5 to +2. So that's what's undergoing reduction. So now that we know that calcium is the substance being oxidized and nitrogen is being reduced, we now have to write out the half reactions. Now I kind of wrote them a little bit lower here so that I can fit in some of the graphics for the other steps. But the half reaction for calcium is going to be just like this. You have calcium going from 0 to +2, and that means you're going to lose 2 electrons, so the charge balances on both sides of the reaction. If you look very carefully, you can see that the net charge on the left-hand side of the reaction is 0, and the net charge on this reaction is also 0 because it's calcium +2, but you also have 2 -1 electrons on that right side of the equation. So charge is balanced on both sides of the equation with 2 electrons there because calcium is losing 2 electrons. The reduction half reaction is nitrogen going from +5 to +2. So here we have to gain 3 electrons in the reduction half reaction. And so there's our reaction for our half reaction for reduction. Nitrogen +5 plus 3 -1 electrons yields nitrogen +2. Well, so far we haven't really done anything new in balancing reactions, but now we're going to look at our 2 half reactions and look at the electrons. And what we have to do is we have to figure out an integer that I can multiply these half reactions by so that the number of electrons is equal in both of the half reactions. Now, the electrons for in the oxidation half reaction are 2, and the electrons for reduction half reaction are 3. So you have to think of the least common multiple of those 2 numbers, which would be 6. So to make the electrons equal to 6 for the oxidation half reaction, we need to multiply that reaction by 3. And then we need to multiply the reduction half reaction by 2 so that the electrons will both be equal to 6. And we're going to distribute that 3 and 2 throughout the whole reaction. So we're going to multiply everything in there by 3, and everything in our reduction half reaction is going to get multiplied by 2. We're going to rewrite those 2 reactions and then add them together. And when we do that, okay, so by multiplying it by that 3, we get the balanced half reactions. We eliminate the electrons, and then we just combine those 2 reactions in there. Now, you got to remember, the 3 right here was carried through, and that gives me 3 calcium 0. It gives me 3 calcium +2s in the products, and it gave me 6 electrons in the final answer here. And then for the reduction half reaction, we have to distribute the 2 through, so we get 2 nitrogen +5s. We get 6 electrons in the reactants from right here, and then we have 2 nitrogen plus 2s in our product. So what I did, some people don't like to skip this step. I actually did it on this flip lesson to kind of uh, cover the space here of the graphic, but some people like to distribute that 3 and 2 and rewrite the half reactions out and then just combine them together. Everything on the left-hand side of the arrows right here has to be in the left-hand side of the whole reaction right here, and then everything on the right-hand side just gets written out as one long string of products right there. So if I just erase all these lines really quick so you can see, this is our net skeletal reaction for this redox reaction. And if you look very carefully, you can see that now the electrons are equal on both sides. We can actually cancel those 6 electrons out. And what's left behind now is our net skeletal reaction. It will be 3 calcium 0 plus 2 nitrogen plus 5 yields 3 calcium plus 2 plus 2 nitrogen plus 2. Now, you'll notice that there's a bunch of stuff that's missing from our redox reaction. You'll see up top here that we didn't include hydrogen and we didn't include oxygen in our net skeletal reaction. That's why it has the word skeletal right there. We only concerned ourselves with the substances that actually underwent reduction and oxidation. And if you decide to go into a later chemistry course, we'll actually then substitute in these coefficients into the balanced chemical reaction and then try to figure out how much of all the other substances we need to have. But for Regents chemistry, all that we really need as our final answer in a balanced redox reaction is the net skeletal reaction right there with the electrons canceled out. All of the other ions whose oxidation numbers don't change, we refer to them as spectator ions, and they're not actually part of it. So what we're going to do is walk through one other one here, and then you're going to practice some on your own and bring them into class, next class. We have magnesium plus hydrochloric acid yields magnesium chloride and hydrogen gas. First step is to write in all the oxidation numbers, and I just do this quickly for you here. We pop in all the oxidation numbers in properly for that reaction. The next thing we have to do is identify what's being oxidized and what's being reduced. The substance that's being oxidized is the one whose oxidation number goes up because it's losing negative electrons. So magnesium is our substance that's actually undergoing oxidation. It goes from 0 to positive 2. And hydrogen is the one that's actually being reduced because it goes from +1 to 0. Magnesium is gaining electrons, causing the oxidation number to, magnesium is losing electrons. That's why the oxidation number is going up. And hydrogen is gaining electrons, and that's why the oxidation number is going down. Now, the next thing we want to do is write in the half reactions for this chemical reaction right here. So, writing out the oxidation reduction half reactions, well, magnesium is undergoing oxidation. It goes from 0 to positive 2, so we need 2 electrons in the products that are showing them being lost. And then hydrogen is actually gaining electrons. But you got to be a little careful here. You got to remember that hydrogen is diatomic in the products. So real quick here, I'm going to have it pop up nice and pretty underneath where we have oxidation here. But when you have a diatomic half reaction, you have to write it diatomic in the products, and then for the hydrogen ion, which has a +1 charge, we're just simply, since we have a little 2 down here, we're going to put a big 2 in front of the H +1 ion, and then we need to add in the number of electrons that we would need in order to balance out the charge on both sides. And so it's very important that we remember that there's got to be 2 electrons, 1 for each of the hydrogens. So in a diatomic half reaction, we have to remember to double the electrons and to put the little 2 with the one that has the element that has the 0 charge, and the big 2 is in front of the element that has the charge or has an oxidation number. So now that we have those written out, if we look at our 2 half reactions, well, life is pretty easy for us. For the step 4 here, is we have to multiply the half reaction by a number so the electrons are actually equal. Well, in this case, they actually are equal, so there is nothing that we need to really multiply them by. I guess you could say we're multiplying them by 1, but for all intents and purposes, all that we're going to be doing here is just taking everything that's on the left-hand side of those 2 arrows and write it as one long continuous string of reactants, and then everything on the right-hand side, we're going to write that as one long string of products. And that is our net skeletal reaction that we end up having there. And our electrons, well, they're written in gray, but they actually cancel out there. And there's our balanced skeletal equation. You'll see that chlorine does not appear because it is a spectator ion. Its oxidation number did not change in this half reaction right there. So that's all there is to balancing reactions. There are 5 problems, and those are the previous reactions that we already wrote half reactions for. So if you have the half reactions written properly for these 5 reactions, you have 2 here on this slide, and then there's actually 3 more on the other slide. You need to practice those and bring those in as part of your flip lesson in order to get full credit for your flip lesson, and then we'll actually even practice more in class the next day. But you need to have these 5 done in order to receive full credit on your flip lesson for next class.